శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ 2008 లో స్థాపించిన కళాశాలలో MBA, NAC A గ్రేడ్ మరియు ISO సర్టిఫికేషన్ సాధించిన మొట్టమొదటి కళాశాల శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ త్వరలో అటానమస్ కాబోతోంది.
2014లో ISO గుర్తింపు, 2015లో రాష్ట్ర ప్రభుత్వంచే A గ్రేడ్, 2016లో NAC A గ్రేడ్, ఇప్పుడు NBA సాధించిన సంస్థ శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ.
Good morning students, I am Harsha, assistant professor from the department of EEE. I am going to teach the subject for 3rd BTech first sem students, and the subject name is renewable energy sources. Good morning to all. In this session we are going to learn about solar photovoltaic cells. So in the previous session we have learned about solar still. In this session we are going to learn about solar photovoltaic cells. You know about photovoltaic cells. So by using this solar energy directly you can convert into an electrical energy. So you can generate more millions of energy by using the photovoltaic cells. So this happens the millions of times to produce the electricity. So let us see what is meant by solar photovoltaics. So converting solar energy directly into electrical energy. So you can convert your solar energy directly into electrical energy. So devices used are called solar panels. So in order to use these solar photovoltaic cells, so you need an solar panel. So whenever the solar panel gets observed by the heat of sunlight, so then your photovoltaic cell will be charged. So another thing, solar panel is a group of solar cells, and the solar cells works on the principle of photovoltaic photoelectric effect. So you know all the structure of an solar cell. So a typical solar cell is nothing but a multi-layered unit of consisting. So you know all, it consists of cover, anti-reflecting coating and front contact. So in the photovoltaic cell you know about N-type semiconductor layer and P-type semiconductor layer, and you can see the back contact also. So let us see about a cover. It is nothing but a clear glass or a plastic layer that provides the outer protection from the elements, and transparent holds the glass to rest of the solar cell. So in order to observe the heat there will be a solar glass which is of a plastic layer, and it is for the protection from the elements, and it also holds the glass to rest of the solar cell. And next one is anti-reflecting coating. This substance is designed to prevent the light and to strike the cell and from the bouncing of maximum energy into a cell. So in order to observe more electric energy there will be an anti-reflecting coating. So it can directly observe more heat energy, and the heat energy can be converted into electrical energy. So and next one is front contact, which is nothing but which transmits the electric current. And next one is N-type semiconductor. You know P-type and N-type semiconductors, and it is nothing but N-type semiconductor. It is nothing but is a thin layer of silicon, and which has been mixed process called doping with phosphorus. And next one is P-type semiconductor layer, which is a thin layer of silicon, and it is mixed or doped with a boron. And it is N-type is mixed with an phosphorus, and P-type is mixed with an boron. And back contact, which transmits the electric current. So in the back contact is nothing but which transmits the electric current. And you can see the panel here, clear panel of the image. There is an PN junction here. You know about PN junction. In diodes you will know about PN junction diode. There is a P layer, N layer, like that. In the same manner you can see here P-type layer and N-type layer, PN junction diode. And there is an cover glass which is transparent, and it has an anti-reflection coating in order to absorb more heat of the sunlight. And there is a front contact, and whenever the sunlight hits this panel you will receive this front contact. And there is an N-type N-layer semiconductor is also there, and P-layer semiconductor is there, and back layer in order to transmit your current. So this is the image of the solar photovoltaic cell. So this is a whole panel. In this whole panel, I am repeating again, there is a cover glass, transparent adhesive, and next one is anti-reflecting coating, and there is an N layer semiconductor, P layer semiconductor, and there is a back contact and PN junction, and there is a front contact with which sun directly reflects on the front contact, and you can generate your electrical energy, and you can transmit your current, and you can use for the domestic and all the purposes. Okay, let us go for the next slide, and let us see what is meant by what is the working of the solar cell. So all solar energy works on the principle of photoelectric effect. So what is meant by photoelectric effect? Let us see. When a light of a certain frequency falls on the surface of the metal, so whenever this light falls on the surface of the metal, the electrons will absorb the energy. So if incident light energy is greater than work function of the metal, I mean to say minimum energy required to remove the loosely bound valence electrons. So whenever the sunlight hits the panel, there will be minimum energy is required to remove these valence electrons. So these will form an flow of electrons, and these flow of electrons are directly used. Okay, and next one is then the photoelectrons will be emitted, and the excess energy is converted into kinetic energy of the electron. So like this you can use your solar cell. So this is the working of the solar cell. I am repeating again. So when a sunlight of a certain frequency falls on the surface of a metal, electrons will absorb the energy. So if incident light energy is greater than work function, and it is directly lose these bond valence electrons of the metal, so whenever these photoelectrons will emit, the excess energy will be converted into kinetic energy of the electrons. So the flow of electrons will balance it, and you will get an electrical energy. So like this your solar cell works. Next one, you can see here the image of the photon layer, p-type layers and n-type layers, and there is a front contact grid and back contact, and all about this n-type and p-type, and these two layers forms a junction. So whenever solar panels are placed in the sunlight, so the photons will strike the surface and emits the electrons. As a result, an electron hole pair is created in the solar cell. So when external circuit is connected to the solar cell, electrons flow in the circuit and current is generated. So whenever there is an external circuit to the panel, so from the external circuit you can flow your current to the different sources. So like this you can use your solar cell. So these are I am repeating again, these solar panels are placed in the sunlight, and the photons will strike the surface. I mean to say, so whenever the sunlight hits this panel, so the absorption of the heat will be done, and these photons will strike and emits the electrons, strike the surface and emits the electrons. So when external circuit is connected to the solar cell, so the electrons flow will be directly, you can whenever if you connect this external circuit, I mean to say if there is any direct circuit, means you can directly connect this circuit to the solar panel, and the current will be generated. So what are the different types of solar electric system? So you can see here a standalone system and grid tie solar system. So let us see about the standalone system. So standalone means it is also called as an off-grid, and these power systems consist of a solar panel and a battery tank. So standalone, for the standalone system there will be a solar panel and a battery tank. So used in rural areas and regions where there is no access to utility grid. So when there is no option of grid, then you can use it in mostly for the rural areas, and very good, and it is very economical for the electricity. So this is about standalone system, and next one is grid tie solar system, and it is very useful for the homes and that are already linked to utility grid, and primary advantage is cheap price of the utility, and the system needs to be wired with the inverter and creates the AC electricity which is needed for you. So I mean to say, you can use this grid tie system in your home directly by converting your by using the converter and the battery tank in your home. So this is very cheap price. You can cheaply buy this nearly 10,000 or 12,000 like that. You have to buy a battery and you have to buy a converter unit in order to convert and DC into AC again. So by using the inverter, so you can use your electricity in your home. So these are the two types of the solar electric system. And you can see this image of stand alone off grid. So you can see the block diagram for the stand alone off grid. So you can see whenever the sun hits this solar array, the DC current will be generated, and this DC current is sent to the charge controller, and this charge controller again it sends to the battery. From the battery you will get this DC current, and in order to use this current, the DC supply will be sent to the inverter, and inverter will convert this DC supply into AC supply, and you will generate the AC current, and directly this AC current can be used to your home purpose like fluorescent lamps, TVs, radios, computer, refrigerator, fan, pump, AC loads like that. So you can use this stand-alone off-grid. Let us see the main application areas for the off-grid. So for the water pumping, you will use these solar panels, and for the space, and for the in spaces also mostly these solar panels are used. And next one is solar home systems and telecom systems, like that you will use this off-grid solar system. And you can see this next grid connected system. You can see the grid connected, so directly from the grid directly from solar panel, the DC line is sent to the inverter, and from the inverter it is sent to the grid supply. So you know all by using the inverter you will convert an DC supply into AC supply, and this AC supply is sent to the grid, and from the grid it will send your homes. So like these grid connected systems are available by using the solar energy. So and what are the main application areas in order to connect your grid means there is a residential home systems. So for the residential home system nearly 2 to 8 kilowatt, and for the commercial building systems there is 50 kilowatt, and PV power plants 100 kilowatt, like that we will use these solar panels. So you can see the solar power solutions by using these PV modules. So and from the PV modules it will it's sent to the charge controller again, and again it is sent to the battery, and through battery it is sent to the inverter, and through inverter, from the inverter it is sent to the home power, industrial power, leisure, mobile, like that you can generate the solar energy by using the photovoltaic system. And you know all the uses of the energy: heaters, cars, lights, satellites, dryers in our daily life, in our domestic lives and industrial applications. We can see all these things of by using the solar energy you can operate all these applications: greenhouses, water pumps, desalination, chilling, solar powder, thermal, and it can also be used for the commercial use also, like office buildings, roof areas, shops, remote buildings, schools, communities, developing countries, and like solar panels are very useful. Okay, 5 kilometer solar telephones are also used here. So this is about uses of solar energy. And you can see the applications here. You can see the solar car and solar heater, solar lights. Okay, and you can see the basic structure of the solar cell. We are going to see about solar cell. I have already told you there is N-type semiconductor and P-type semiconductor, and back current, anti-reflection coating, and front contact, and current flow solar module panels. So there are different types of solar module panels. You can see this solar cell module array, cell module array. So an individual PV cell typically produces between 1 and 2 watts. Okay. And next one is in our state, in our India, solar photovoltaics in India. You can see that solar photovoltaics in India. So there is an postage stamp established by the Indian government also, and you can see that began as far back as in the mid 70. Solar photovoltaics program of the government of India is one of the largest in the world, and reliefs offered by the government on SPF manufacturers and the users of SPV based products, and 100% depreciation is the first year of the installation of the system. So government is offering some schemes in order to use these solar photovoltaics. So government is giving subsidies also, so you can buy the solar system by the subsidies also. So by using the subsidies you can reduce the amount also. Okay, so and for the manufacturers also, and their government is providing loans also in India. And you can see the solar cell, the principal PN junction diode. You know about PN junction diode. There will be P layer and N layer. There will be a depletion layer, which is a junction, and positive will be attracted to negative and negative will be attracted to positive. There will be a P layer mode, and there will be a junction mode. So you can see here there is an P type. In P type there will be holes which is fixed acceptor impurity ion, and fixed donor impurity ion, and this P type will be attracted to N type, and N type will be attracted to P type, and forms the junction. In the junction you can see there is a negative space charge and there is also a positive space charge. So you can see the images of solar panel also, grid connected, which is anti-reflecting, and electric field region, ohmic contact, P type, N type semiconductors are there. And let us see about photovoltaics in systems capacity less. So for the community lighting systems, 1 kilowatt to 2.5 kilowatt, and for the small householding lighting system is there 1 kilowatt to 2.5 kilowatt. And for the portable solar lanterns, 10 watt power to SPV module, which is nothing but a light 7 watt CFL lamp for the 3 hours a day, and for the street lights 75 SPV module charging 100 to 130 amperes, like that batteries are available. And for the fixed home lighting system, 35 to 50 watts solar PV module, and CFLS bulbs like 11 watt working for 4 hours, running a small TV. You can run a small TV also. And for the water pumping, 1 kilowatt DC motor and shallow pumping also there. And you can see the practical applications of the solar energy here. Solar powered auto rickshaw. So nowadays day by day the technology is improving day by day the technology is improving in solar energy. So innovations are coming like this. So solar panels, auto rickshaw, so which is auto powered with auto rickshaw solar, it runs with the solar power. And also we have NASA designed solar powered vehicle Helios, so which has NASA designed, which is nothing but a NASA designed this solar powered vehicle Helios. So you can see the image here. It's a dried flight research. For the research purpose these Helios are used. Next one, you can see these practical applications of the solar energy here. Semi-autonomous war mission. So these are used for war mission. And you can see the car, solar quant. So this car is of solar, and so you can see the solar cell characteristics. These photovoltaic cells have a non-linear IV curve, like the you can see the images here between P and V, and the curve shifts depending upon the environment condition like temperature and incident light intensity. So depending upon the weather conditions and the temperature and light intensity, you can see this graph. And the PV curve has an characteristics of maximum power point. There is a maximum power point characteristics between voltage and current. So there is an image here, you can see the PV curve from the photovoltaic cell. You will get a curve, and there are mismatch losses, series losses, shunt losses, and power maximum. So you will get like that. And VOC voltage, no voltage, and voltage V, ISC short circuit current, and no load voltage. So like this the curve obtained. So this is IV curve, short circuit current, maximum power. So you can see the formula: no voltage, V is equal to VOC, and I is equal to 0 here. So nearly you are getting 3000 amperes current, and you can see the voltage here, 225 voltage. And these are the collectors used for the solar decrease area of solar cell. Again there are two types of collectors. One is flat type, another one is concentrated collector. decreases the area of the solar cell and material being used in a system. So there is a Fresnel lenses here housing secondary optics, cell assemblies, secondary concentrator, electric contact. Like this we have concentrator collector, and you can see the flat plate collectors. There is a cover film, solar cell, and substrate, cover film, seal, gasket, frame. So these are all about flat plate collectors typically used for the large area of the cells. So in order to place the large area of cells, these flat plate systems are designed. And for the metal, these substrates are metal, glass and plastic, and they are very simple to design and fabricate. So they do not require special optics and specially designed cells for mounting the structures, and that must track the sun precisely. Plus, and flat plate collectors can use all these sunlight. Okay, thank you all. I hope you all understood about solar photovoltaic cell. If you have any doubts, free to call me. Thank you all. We will meet in the next session.
In the last 2 decades, the contribution of solar energy to the world's total energy supply has grown significantly. This video will show how solar cell or photovoltaic cell produce electricity. Energy from the sun is the most abundant and absolutely freely available energy on planet Earth. In order to utilize this energy, we need help from the second most abundant element on Earth, sand. The sand has to be converted to 99.999% pure silicon crystals to use in solar cells. To achieve this, the sand has to go through a complex purification process as shown. The raw silicon gets converted into a gaseous silicon compound form. This is then mixed with hydrogen to get highly purified polycrystalline silicon. These silicon ingots are reshaped and converted into very thin slices called silicon wafers. The silicon wafer is the heart of a photovoltaic cell. When we analyze the structure of the silicon atoms, you can see they are bonded together. When you are bonded with someone, you lose your freedom. Similarly, the electrons in the silicon structure also have no freedom of movement. To make the study easier, let's consider a 2D structure of the silicon crystals. Assume that phosphorus atoms with 5 valence electrons are injected into it. Here, 1 electron is free to move. In this structure, when the electrons get sufficient energy, they will move freely. Let's try to make a highly simplified solar cell only using this type of material. When light strikes them, the electrons will gain photon energy and will be free to move. However, this movement of the electrons is random. It does not result in any current through the load. To make the electron flow unidirectional, a driving force is needed. An easy and practical way to produce the driving force is a p-n junction. Let's see how a p-n junction produces the driving force. Similar to n-type doping, if you inject boron with 3 valence electrons into pure silicon, there will be 1 hole for each atom. This is called p-type doping. If these 2 kinds of doped materials join together, some electrons from the n side will migrate to the p region and fill the holes available there. This way, a depletion region is formed, where there are no free electrons and holes. Due to the electron migration, the n-side boundary becomes slightly positively charged, and the p side becomes negatively charged. An electric field will definitely be formed between these charges. This electric field produces the necessary driving force. Let's see it in detail. When the light strikes the p-n junction, something very interesting happens. Light strikes the N region of the PV cell, and it penetrates and reaches up to the depletion region. This photon energy is sufficient to generate electron-hole pairs in the depletion region. The electric field in the depletion region drives the electrons and holes out of the depletion region. Here we observe that the concentration of electrons in the N region and holes in the P region becomes so high that a potential difference will develop between them. As soon as we connect any load between these regions, electrons will start flowing through the load. The electrons will recombine with the holes in the P region after completing their path. In this way, a solar cell continuously gives direct current. In a practical solar cell, you can see that the top N layer is very thin and heavily doped, whereas the P layer is thick and lightly doped. This is to increase the performance of the cell. Just observe the depletion region formation here. You should note that the thickness of the depletion region is much higher here compared to the previous case. This means that, due to the light striking, the electron hole pairs are generated in a wider area compared to the previous case. This results in more current generation by the PV cell. The other advantage is that due to the thin top layer, more light energy can reach the depletion region. Now, let's analyze the structure of a solar panel. You can see the solar panel has different layers. One of them is a layer of cells. You will be amazed to see how these PV cells are interconnected. After passing through the fingers, the electrons get collected in bus bars. The top negative side of this cell is connected to the back side of the next cell through copper strips. Here, it forms a series connection. When you connect these series-connected cells parallel to another cell series, you get the solar panel. A single PV cell produces only around 0.5 voltage. The combination of series and parallel connection of the cells increases the current and voltage values to a usable range. The layer of EVA sheeting on both sides of the cells is to protect them from shocks, vibrations, humidity, and dirt. Why are there two different kinds of appearances for the solar panels? This is because of the difference in the internal crystalline lattice structure. In polycrystalline solar panels, multi-crystals are randomly oriented. If the chemical process of silicon crystals is taken one step further, the polycrystalline cells will become monocrystalline cells. Even though the principles of operation of both are the same, monocrystalline cells offer higher electrical conductivity. However, monocrystalline cells are costlier and thus not widely used. Even though running costs of PV cells are negligible, the total global energy contribution of solar voltaic is only 1.3%. This is mainly because of the capital costs and the efficiency constraints of solar voltaic panels, which do not match conventional energy options. Solar panels on the roofs of homes have the option to store electricity with the help of batteries and solar charge controllers. However, in the case of a solar power plant, the massive amount of storage required is not possible. So, generally, they are connected to the electrical grid system in the same way that other conventional power plant outputs are connected. With the help of power inverters, DC is converted to AC and fed to the grid. Please support Learn Engineering's educational activities on patreon.com, and also, don't forget to subscribe to our channel. Thank you.